Today going to start looking at some of our statistics work. The next couple of weeks are going to be kind of a back and forth between starting statistics, which is our final unit of the year, and also doing some OST prep work and getting ready for the OST. So we have about a week and a half until OSTs, math OSTs. Okay, so that means next week is our last full week before those tests. We're going to do some days where we're doing statistics lessons, some days where we're going to do some state test review, where I'm going to try to go through, okay, in August we started with factors, multiples, GCF, LCM. Let's review that. Make sure that that's fresh into your head going into the test, okay? So what I pulled from statistics, because there's not time to get through the whole unit before the test, I pulled kind of the biggest pieces from our statistics unit to do over the next week, things that I think are most likely to show up on the test, to at least give you some background on that. But we won't finish statistics till after state testing. Yes?
Did you grade our tests?
No, tests are not going to get graded till next week. Okay, we'll get those back to you sometime next week. Okay? All right, so all you need out for today is a pencil. You can put your notebooks, your calculators away. You don't need those anymore. Here we go. All right, first thing we're going to talk about is variability. And you guys are actually with me during STAR, so we're going to look more at finding variability then. But variability is a word that describes how much the data values in a data set differ or vary from each other. So there's kind of three types of variability. If a statistical question that we're collecting data on has high variability, it means that the data values are really spread out. If a statistical question has low variability, it means that the data values are pretty close together. And then if a statistical question has no variability, it tells us that the data values are all the same. Okay, we're going to talk about the measure of variability range during STAR this week. Okay, so I'm going to give you an example of three statistical questions, and I want you to think to yourself, which of these questions I'm going to tell you has high, which one has low, and which one has no variability. Okay, here we go. First question, if I were to take a survey and ask all of the students in this class how many bikes your family has at your house. I'm not asking you to actually count right now. That would just be my first statistical question, thinking high, low, or no. Second statistical question I would ask, what if I were to survey all of the students at LMS and ask them how many days until your next birthday? So high, low, or no. And then my third statistical questions, if I were to ask the sixth graders in this class how many shoes you had on your feet when you walked in the front door this morning. Which of those questions do you think would have high variability? High variability. Anna? The birthday one is going to have high variability. I've probably got people in this school who have a birthday in the next day or two. So their days till their birthday would be 1, 2, 3. But I also have people in this school that had a birthday within the past week. So their answer would be like 360 or 358, something like that. That's a pretty big range of numbers. That would be high variability. Which one has low variability? So it was bikes at your house, shoes on your feet. Lola.
Bikes at your house.
Bikes at your house. There are probably people in this class that don't have any bikes at your house. My family, we're not bike riders. We don't own a bike. Okay. There are also probably people in this room that, like, everybody in my family has their own bike. Oh, I have 2 bikes because we never got rid of my old one, something like that, right? But I would anticipate that nobody in this class probably has more than 10 bikes at their house. Okay. Like, nobody is living in Grandview with a bike or with a garage that holds 400 bikes at your house, right? So you're not going to have very high variability on that. We're going to have some differences in responses, but it's going to be relatively low. And then no variability. Miles?
Shoes. And also, why is it April 40th?
Shoes on your feet would be no variability because every single one of you should have walked in the front doors with 2 shoes on your feet when you came to school today. I was going to say, how many shoes are you wearing at this moment? But when I looked around the room, some of you had slipped your shoes off while I was talking, so I couldn't ask that actual question. Okay, so that is the difference between variability. Questions on that?
Oh, and this isn't really a question, but I almost walked out the door this morning with no shoes on.
No, I hope you would have figured that out. All right, next thing to talk about. There are a variety of graphs that as 6th graders you are responsible for kind of knowing and being able to read. 2 of those graphs are shown here. So we've got a line plot and we've got a dot plot. What observations can you make about these graphs? Leo?
The dot plot uses dots and the line plot uses X's.
The dot plot uses dots and the line plot uses X's. Griffin.
On the line plot, the lower numbers have like more like X's, and then on the dot plot, the higher numbers have more dots.
Okay, so for these two specific examples, which is fine. Yep, the ones we're looking at on the line plot, more of our data is centered around the lower numbers. On the dot plot, it's kind of the middle to high numbers there. Audrey?
The dot plot has like just one straight line like going, and the line plot has like a L.
Oh, so yeah, so that is just kind of how these two are set up. They could both have kind of this y-axis or they could not have it. So basically these two graphs function the same way. You're going to have some sort of number line that you're going to plot your data points, and literally really the only difference between these two is a dot plot uses dots as your data points and a line plot uses X's. Why are there two different graphs? I don't know. I didn't make them, okay? I just am teaching you about them, okay? So, we would read these as each of the dots or the X's represents one data point. So, for example, if I was looking at the dot plot and telling you that this dot plot represented, I polled sixth graders and asked, how many minutes were you on task for during STAR last Thursday?
3.
Okay. How many students said that they were on task for 26 minutes last Thursday during STAR? 1. How many students said they were on task for 32 minutes during STAR? 0. How many students said I was on task for 29 minutes during STAR? 4 people. Okay, so each of those dots represents one person or one response. Sometimes with dot plots or line plots, we see kind of a key or a legend, kind of like looking at a map, and it might look something like this.
What does one have dash?
One dot represents, it's just the way they're set up, okay? 1 dot equals 10 people. So if this were kind of our key here and each dot represented 10 people, how many people would have said 27 minutes now? 20, because each of these counts as 10. I've got 2 dots, that's 20 people. Questions on those?
No.
Lola?
Like, was there a specific time where you would use each of them?
No, like if you were using them to display data, unless it said make a dot plot or make a line plot specifically, you could choose to use either one. They both show data in the exact same way. Griffin?
Does the line plot have like the same key? Can it have the same?
It could, yes. So the line plot, except here it would look like this. X equals 10 people. So each X there. Emily?
Are the line plots always X's or
Yep.
can they?
Yep. X's. It's not, the X isn't really a variable, it's just a symbol here. Alice?
So the line plots used for lower numbers and the top.
Nope. Good question. They could all represent any kind of number. So I could make a dot plot that shows 1 through 10. I could make a line plot that shows 150 to 200. It just kind of depends on what your data set is and what numbers it represents. All right, so let's look at this question and see if you can come up with the answer interpreting this dot plot. It says the dot plot shows shows the scores for 15 students on a 5-point quiz. The teacher stated that 9 of the students passed this quiz. 1 student incorrectly claimed that the lowest passing score for this quiz was 5 points. What was the correct lowest passing score for this quiz? Take a second, see if you can come up with what the lowest passing score for the quiz was and how you know. Anna, what do you think?
3 points.
3 points. How did you come up with that?
Because there's 9 that are 3 or higher, and 9 of the students passed.
Yep, so if it tells us that 9 of the students passed, the highest passing score would be a 5. So 4 people got a 5. So we've got 4 people, and then we've got 3 more people that got the next score, so that's 7 total. And then we've got 2 people here. That gets us the top 9 scores. So the lowest passing score would be a 3 because that's where the top 9 scores fall. Make sense? Okay, what about this one? Oh, just kidding. I forgot I was going to new graph. Okay, we've got a new graph here. This one is called a histogram. What does the histogram remind you of? What kind of graph, Audrey?
A bar
A bar graph. You've been creating bar graphs probably since like kindergarten, first grade. You probably graphed what are our favorite colors, and everyone went around and shared their favorite color, and we had a bar that represented these people said blue, and this number of people said pink, and whatever, right? There are two main differences between a bar graph and a histogram. Does anyone see one thing that's different?
They have like the numbers of how many students on the side, and they have like lines going across like to show that.
Like these lines are you talking about?
Yeah.
Yeah, so that isn't necessarily histogram specific. It's just that this graph was maybe created on lined paper, or it could have graph paper where it's going both ways. Okay, but that is specific to this one. Yep. What's another difference you see? Skylar?
There's like numbers on both sides, one for like the number of students and then the age of the students.
Okay, so there's numbers on both axes. Leo, add to that.
The age of the students are two ages instead of one.
Yeah, so this is our first major difference between bar graphs and histograms. At the bottom on the x-axis, we have these ranges of numbers that are called intervals. So a histogram, each bar doesn't represent just one thing. It represents a range or an interval of data points. So anyone who was 14 or 15 fell in this bar. So there were 60 students that were either 14 or 15. There were, looks like maybe 30 students that were 16 or 17. Okay, so those intervals are specific to a histogram. What's another difference you notice between this and a bar graph? It's not quite as obvious.
There's like no space between the bars.
Yeah, that's the other major difference. On a bar graph, generally you're going to have a bar and then there's going to be a space. And then you're going to have your next bar. So here are the people that chose blue and then a space. Here are the people that chose pink. On a histogram, there is not space between the bars because it's kind of showing that this data is continuous. It just keeps on going with those ranges. Quinn?
I don't know if this is a coincidence, but it just keeps going up from left.
Going up or down? From the left, it goes down, right?
Right.
Yeah, so that just happens to be how the data in this specific set falls. It's not that it has to do that. Cora?
I don't know if this is just specific to this graph, but like it ranges from certain numbers. Kind of instead of a specific number.
Yep, so that's the first major difference between this and the bar graphs, that you're always going to have some range down here instead of one specific number. Good. David?
It uses filled in boxes instead of symbols.
Yep, so it's just like a bar graph. So we've shifted to a new type of graph. Yep. All right, so let's see if we can read and interpret some of these. So I've got this graph that's showing ages and the number of people. I don't know specifically what data it's representing, but the question is, what is the number of people above the age of 60 in the above histogram? How many people in this, bless you, histogram, how many people in this histogram are above 60, Cam? How'd you come up with 5?
So 61 to 70, there's 3, and then 71 to 80, there's 2, and those are all above 60.
Good. So these last two bars are representing people above 60. So he combined how many total data points were in each of those. Okay, good. Nice job. What about this one? Kind of a strange survey here, but it says a study was conducted to examine the relationship between a person's weight and pet ownership. The histogram above shows the average number of pets owned per weight group. What weight group had the highest average number of pets? Not quite sure why somebody would want to know this, other than like if I have a dog, maybe I'm walking my dog every day, but like owning a pet fish isn't probably going to have an impact on my weight, I don't think. Emily?
Eat the fish. The highest thing is 160.
Good. Right here, our highest bar, the one that goes the tallest, is 160 to 179. Excellent. All right. Next thing to talk about is statistical questions. So a statistical question is a question that I would ask trying to collect data, and it's one that we would anticipate there's going to be variability, meaning I can get lots of different answers. It might be high variability, it might be low variability, but I'm looking for some sort of variability in that question. It's typically not going to be a yes or no question, and it's definitely not going to be a question that's directed towards one person. So I'm not going to ask like, what did you have for breakfast this morning? Because you're one person, you're going to have one answer. That's not a good statistical question because it's not going to give me a range of answers. But if I ask, what did the 6th graders in my class have for breakfast this morning? I'm going to get a variety of answers. I didn't eat breakfast. I had cereal. I had toast, whatever it is. okay? That kind of question is a question that has qualitative answers. Have you in science talked about qualitative versus quantitative? Yeah. So qualitative would be I ate toast, I ate cereal. It's not a numerical, a number thing. But quantitative, I could say, how long did the 6th graders in my class spend eating breakfast this morning? That's going to be a quantitative question because you're going to answer with a number instead. Okay, so I've got a set of questions here. We're going to go through the list and determine whether we think they're statistical or not. So first one, what are the colors of shoes worn by students in my school? Statistical or not? Do I have multiple students?
Yeah.
Do they have different color shoes?
Yeah.
That is statistical. I can go survey all the students in my shoes. Or all the students in my shoes. That would be weird if I had students in my shoes. I can survey all of the students in my school. What color shoes do you have? And I'm going to get a whole slew of data from that. Okay. How many letters are in my last name? No. I am one person. My last name implies it's me. We're talking about me. I've got one last name. It's got however many letters and I'm done. Okay. How many pets does your science teacher have? No. Okay. How could I change that question and make it statistical? What could I do to make that statistical? Lola.
How many pets does my student science teacher have?
Well, that's still going to be the same person, though. It's just looking at Miss Lyle still, because my students all have the same science teacher, right? Cora?
If you did like the different kinds of pets you have, like.
If she has different kinds of pets, maybe we want to open it up and have a broader scope that we're looking at. Griffin?
How many pets does my teachers have?
How many pets do my 6th grade teachers have? So you can go down the row. How many pets do the science teachers in my school have? Now I want to know Mrs. Hepp, Mrs. Walker, Miss Lyle, Mrs. Williamson, Mrs. Richter. I've got a variety there. Okay, so opening that up to a broader audience is going to change that. How old are the students in my school? Yes, I can go ask a 4th grader. I can ask an 8th grader. I can ask a 7th grader. I'm going to get a lot of different answers here. How tall is your 6th grade math teacher? No, 6'7". How many pockets are on the clothes of students in this class? Yes, that is a yes. What are the favorite colors of 6th graders at LMS? Those are our old initials. How many languages do I speak? It's going to be one answer. One fluently. I can speak a little bit of Spanish. How old is the principal at our school?
No. Wait.
What is the
Principal.
what is the favorite subject of 6th graders at my school? Yes. How many siblings does my best friend have? No. That's going to have one answer. Good. All right. We are going to look at 3 last questions. These are all released OST questions, meaning they are statistic questions that have been on the 6th grade math OST in the past. So you can get a sense for kind of what types of questions on some of the statistics stuff we've talked about today you would get asked. So first one, students in a math class watch 15-minute video lessons for homework. Their teacher wants to know how many of his 25 students watched at least 2 hours worth of video lessons last week. Which method should this teacher use? So we got 4 choices here. We're going to read through them, then I'm going to give you a minute to talk to the people around you, and we'll come back together. 1, should he count the number of students who watched at least 2 lessons last week? B, should he count the number of students who watched at least 8 lessons last week? C, should he multiply the total number of lessons the students watched by 8 and then divide by 25? Or should he multiply the total number of lessons the students watched by 25 and then divide by 8? Take a minute, turn and talk, see if you can decide which one is the best answer here. All right, let's put it to a vote. How many people say A, he should count the number of students who watched at least 2 lessons last week? How many people say B, he should count the number of students who watched at least 8 lessons last week? Sure. How many people say B, multiply the total number of lessons the students watched by 8, then divide by 25? How many people said D, multiply the total number of lessons the students watched by 25 and then divide by 8? Okay, we had about 7 people raise their hands on that. So we're going to try this again. Every single person needs to vote here. So I'm giving you 15 seconds. Lock in your head what your final answer is. How many people this time say A? Count how many people watched 2 lessons. How many people said B? Watch how many people, or count how many people watched 8 lessons. Ooh, we've got like a whole half of the room here. How many people say C? Multiply by 8, then divide by 25. Ooh, we're like split 1/2 versus 1/2. Anyone say D? Okay, so correct answer here. If we're trying to figure out how many specific students watched at least 2 hours worth, it is B here. Okay. Somebody on this half of the room that voted for B, why is it 8 lessons that's important? Audrey.
Because 8 lessons, if you do 15 times 8, it's 120 minutes, which is 2 hours. So, like, yeah.
8 lessons is going to be 2 hours worth because they're 15-minute videos. So 15, 30, 45, an hour is 4 lessons. So we have 2 hours would be 8 lessons. The reason why C doesn't work, those of us that picked C is going to combine all of our total lessons watched and divide it by students to see how many students watched. But what it doesn't take into effect is, let's say that Miles didn't watch any lessons, but Emily watched 50 lessons. Her 50 lessons is then getting distributed by like the whole class, and she's still only one person. It's getting averaged there. So you've got to count specific students how many lessons they watched. Good. All right, let's try another one. This one is a question that is a typical OST question where it should be one of the easiest questions you answer, but people look at this and then they start to panic and overthink this, okay? I'm not saying they're all easy questions, but this is one that should be a pretty obvious answer if you read it carefully. It says, Rebecca asks 6 of her friends how many hours they spend reading each week. She creates a dot plot based on their answers. Which dot plot could represent Rebecca's data? I'll read it again. Rebecca asks 6 of her friends how many hours they spend reading each week. She creates a dot plot based on their answers. Which dot plot could represent Rebecca's data? Skylar, what do you think?
I think it's C because there's like 6 people in total, and all the other ones have like 7.
Yeah. C is the only dot plot that shows 6 data points, and she asked 6 people how long they spend reading. Okay. What people do is they get this and they look at it and they start trying to analyze. Well, okay, if I was asking people how long they read, would it make more sense for a lot of people to say 6 hours? Like, I don't think that's realistic, but what about 1? And like, would 2 people say 1 or would 1 person say 1? And like, you start trying to analyze the actual data when it has nothing to do with where those dots fall. It all has to do with how many data points do I have? I only have 6. There's only 1 graph that has 6 points. Good, nice job. Last question on this. It says Michael wants to determine the most popular type of apple at his grocery store. What method will offer Michael the most accurate results? So think about what he could do for a statistical question to collect data. Should he, A, count the number of people who buy apples on a given day? B, count the number of each type of apple on display when the store opens? C, conduct a survey about favorite apples with 200 people in his grocery store? Or D, conduct a survey about favorite apples with 200 people in his neighborhood? Again, he wants to determine the most popular type of apple at his grocery store. You can do this again as a vote. All right. What do we think? What's your gut tell you? Should he, A, count the number of people who buy apples on a given day? Should he, B, count the number of each type of apple on display when the store opens? Should he, C, conduct a survey with 200 people at the grocery store? Yes, that is it. Okay, difference, and I heard this group talking about the difference between C and D is just where that survey is happening. Audrey, I heard you say it should be C because he wants to know the number of, or the favorite at the grocery store. Not everyone in his neighborhood is going to go to that grocery store. So good way to eliminate D. And then these two, I can count how many apples or how many people buy apple, but that's not going to give me any information about like the most popular types if I just count specifically. Okay, David?
Yeah, they could just